issues, environmental problems that are a result of human influences on the environment. We talked about rapid population growth and how the more people you have on the earth, the more resources they require. Resources are food, water, building materials, energy, all sorts of things. And so, as human population has skyrocketed, our use of natural resources has increased, and as well as our damage to the environment. And then we talked about the types of resources that humans use. And we think about them often in two categories: renewable resources or non-renewable resources. Renewable resources are resources that don't get used up, that they are there sort of permanently. Things like wind power. You know, if you have those wind turbines which spin and generate electricity, well, they don't use up the wind. If you have wind turbines, it's not like it's not going to be windy tomorrow because we used up all the wind on one day, and the wind's always blowing. So those are resources we don't run out of. Also, most of them are non-polluting. A wind turbine turning doesn't generate any pollution. No carbon dioxide, no carbon monoxide, no sulfur, no nitrogen. So they're very clean types of energy. They have their own impacts. It's not that they have zero environmental impact, but they have no pollution at least. Non-renewable resources are the things when we basically take them out of the earth. If we dig out some coal from the ground, and then we burn that in a power plant. Well, once that coal's burned, it's gone. It's never coming back. You take it out of the ground, it's gone. But also burning those things like fossil fuels release large amounts of carbon dioxide and other pollutants into the air, which has effects on the environment we'll talk about today. So I just showed you some examples. These are renewable sources of energy. You can use wind turbines to generate electricity.
What makes the wind turbines turn?
The wind blowing.
Oh, the wind makes them turn and generates electricity.
Yeah, anytime you have something, anytime you have any movement, you could harness that movement to generate electricity. So wind turbine had the spinning blade turns a little generator inside of the top of that, which generates electricity, which flows into the power
I
grid.
thought I was confused with what they did. I thought they made wind.
No, they as wind's blowing, they're spinning like a pinwheel, generating electricity. Say a hydropower works the same way. You build a dam, and then you allow water to go through it in a small area. And as the water goes through, it spins the turbine, which turns the generator, which generates electricity. Okay? So they both work on sort of the same principle. They even have wave-powered electrical generating plants where they're in the ocean, and the movement of the waves constantly turn something a turbine which generates electricity. Anytime you have movement, you can use it to generate electricity. There's also solar power, like on your calculator, you know, that tiny little solar cell. When sunlight hits these solar panels, it generates electricity. The electricity can be used. Geothermal energy is the type of energy where you basically are putting pipes deep into the ground where heat is generated, and you can use that energy that's coming out of the earth to warm your house or to actually generate electricity and various things. So all of these things are renewable. They don't get used up. Versus the non-renewables, like these fossil fuels, which do get used up. Coal, which is dug out of the ground, used mainly in power plants. Used to be used in people's houses. You know, people used to have to fill a boiler, a heater with coal, shovel it in there, and to heat their homes. Mostly now oil. Does anybody know that they have a big oil tank in their house? Yeah, they probably come in the winter and they fill it up with oil. Lots of natural gas pipes into your house, which bring natural gas to run your heater and your hot water heater and your stove and everything. And oil from the ground is crude oil. It has to be refined into other products to be used, but that's what it looks like. All right, so now we'll get on to sort of the newer stuff. When we talk about these resources, I'm sure you guys have studied this in elementary school, the 3 R's of reducing, reusing, recycling. These are just ways that we can help to use less of the Earth's natural resources. No, reducing the amount of material we use is always the best. You could reduce the amount we need. And you can do this in many ways. For example, using less packaging on products can conserve resources. You know what plastics are made from mainly?
Recycled plastic.
Well, if they're non-recycled, they're actually a petroleum product. They're made with oil, all plastics. And so the more you can reuse and recycle these things, the less you have to use from the ground. You know, and reducing can be things like, you know, walking somewhere rather than driving, taking public transportation when it's available, driving a more fuel-efficient car, like an electric car, or a hybrid vehicle, or even a vehicle that gets better gas mileage. All of those things help do this first thing, reduce the amount of resources that humans are using. Have you ever bought, like, or your parents probably bought something, like a washing machine, a refrigerator, or TV, and it has that Energy Star sticker on it? Ever seen that?
Yeah.
Those are certified products that are certified to use less electricity than the non-Energy Star version. Dana?
If plastics like are made out of oil, like isn't it bad to like smell burning plastic or something?
Yeah, I mean, if you burn plastic, you release lots of different chemicals into the air.
So like bad.
But recycling doesn't burn them, it melts them. So it's sort of a different thing.
So that last like bad for
To breathe that stuff in, yeah, because those chemicals, with petroleum and all sorts of other chemicals that are not good. All right, reusing is another option, is that if you can take something and reuse it multiple times, then you're going to reduce the amount of resources. You know that I never have a plastic water bottle that I bring to school that I buy, is that I always just refill this one with faculty. Again, that means I don't have to buy and throw away or even recycle all these plastic bottles, helping to conserve some amount of resources. Or if you go to the grocery store, right, and you bring in those reusable bags. Again, you don't have to take a plastic bag and bring your groceries home. And it's only a small thing, but when that's multiplied by many, many people, those small things can add up and make a difference. Finally, recycling. You know, when you do have something that you have to get rid of, rather than throwing it away and having it sort of be put in a landfill, but most things can be recycled. In our area, we have a pretty good recycling program. We can recycle all sorts of different things. We now just put everything in one container. You don't have to sort anything. Put it in one container, put it at the road, and they take away the recycling. And recycling is sort of turning something that could have been waste into something that's usable. You know, we recycle cardboard boxes and stuff. It gets chopped up and put into new types of cardboard boxes. If you recycle a soda can, it gets melted down, and the aluminum is used to make new soda cans again. So it's allowing us to get more out of the resources we're using. Can you?
At Hanford, you can take the bottles and cans back and get 5 cents.
Yeah, those are. No, why is that? Is it 10 cents now? I believe it's 10 cents.
I thought it was 5. 5, but.
it's still
It's
fine.
an increase in price.
Why is that the law? It's not the law in every state. It's been a law now in New York State. Does anybody know why they made that the law? So you know, you don't just get free money. If you buy a 6-pack of Coke, you pay, let's say it's $2.99. But then you have to pay extra money. It says deposit. You have to pay 30 cents extra. And when do you get that 30 cents back?
When you recycle.
Yeah, when you take it back and you recycle it. They give you your 5 cents back. It's called a deposit. Why do they do that?
Because they want
To get people to like recycle.
Yeah, to encourage recycling. That, you know, if you already paid 30 cents and you want that 30 cents back, you're more likely to bring your cans back to be recycled rather than just throwing them away. So it encourages people to recycle.
So they charge you more for the items?
Yeah, they charge you the 5 cents and you get your 5 cents back. Like Diane ever grocery shop at Aldi. You gotta put a deposit on the shopping cart, right? You put a quarter in there, and when do you get your quarter back? When you return your cart back to the rack. Why do they do that?
So they bring it back.
Yeah, to encourage you to put it back, and they don't have to hire somebody to go out there and gather up the carts and bring them in. So yeah, same thing, to encourage people to return them.
But it's just a quarter.
Yeah, but it's just a nickel, but I always bring mine back. I always want my quarter back. I don't-
adds up.
Yeah, it does add up. All right, so those are some things. Now what we're going to start to do is talk about specific environmental problems that are important to know about. And the first one is acid rain. Have you guys heard of acid rain?
Yeah.
Studied?
Yeah.
Sort of, a little bit? All right, so people sometimes get a little confused. They think, well, if there's acid rain, like when you're walking to school and it's raining, you're going to melt, your skin's going to be disintegrating. That's not what acid rain is. Okay? I know you've seen too many movies. Acids are not just things that melt stuff. Okay? Acidity is a property of all liquids. Okay? Pure water is called neutral. It's not acidic. And the other side of acidity is something that's called basic. They're two opposites, and you see that. Acidic, basic, neutral. Distilled water is neutral. There's a scale called the pH scale that measures the acidity of something. A very low number means it's very acidic. A pH of 0 is something that would burn your skin, would do serious damage if you got it into your eyes, like battery acid, strong acids. These are dangerous chemicals.
Does that ever happen?
What?
Does that ever happen before?
Yeah, batteries do have acid in a lot.
Or like 0, but acid rain.
No, not acid rain. Just in other materials.
Oh, that's.
And then as we go up, you see, lemon juice is a little bit acidic, and as we go up, wine and other things, soda is a little bit acidic, until we get to normal. The other side, we have the things that are basic, baking soda, soaps, basic, anything that if you got it on your hands that feels slippery, those are usually basic compounds. Up to ammonia, lye, strong bases are also very dangerous. If you get a strong base on your skin, it will burn your skin. If you get it in your eyes, it will damage your eyes. So both sides of the spectrum are dangerous. But acid rain is a problem, especially in our area. Daniel?
Like, I have acid reflux. Does that mean if I drink like battery
Yes.
acid?
Well, you won't.
I
That
wouldn't
would
get it.
burn your esophagus. But if you eat acidic foods, it can increase your stomach acidity, leading to more acid reflux.
Like pizza.
Yeah. All right, so the pH scale goes from 0 to 14, and lower numbers are more acidic. Now, usually naturally, rain is about 5.6. That's good, that's okay. It's normal rain. But when pollution is released in the atmosphere, specifically sulfur and nitrogen is released in the air, it has a chemical reaction with water in the air, and it turns into an acid. And that can lower the pH of the rain, which can damage ecosystems. Okay? So power plants that burn coal mostly, cars release nitrogen when they burn gasoline. When that stuff gets in the air, it mixes and forms acid rain. That acid rain falls to the ground and can harm ecosystems. Okay? In some ecosystems, the forests have died off because they can't handle these acidic conditions. Some lakes have become so acidic that nothing can really live there. They're called dead lakes. Okay? Because of this low pH, this very acidic rain that's falling on them. Especially a problem in the spring because you have the buildup of snow that might be acidic, and when it all melts and goes into a lake, it creates a sudden drop in pH that can kill animals and plants.
Is that how like statues like the Lady Liberty are like?
Yeah, next slide. Oh, wait, 2 slides. I'll show you those. So if you look here, this is a graphic that shows what happens as the pH of the water goes down, as it becomes more acidic. Okay? So at a pH of 6.5, all of these species are able to survive. But as the pH of the lake goes down, and we're okay still at 6. We go down again, now these mussels, they can't survive at a pH of 5.5. We drop again, now the mayfly and the bass, they can't survive conditions. And as we get more and more acidic, only a couple things are able to tolerate those conditions. So obviously a lot of acid rain falling into ecosystems damages them. It is a major problem in the northeast United States, in our area, in the Adirondacks especially because of the soils there. The red are areas where acid rain is a problem. It shows the pH. And one other problem is that when coal or other products are burned out here in the Midwest, and they get up high into the atmosphere, they don't fall in the Midwest where they were produced. they get trapped in air currents, and many of them come over our way in the Northeast and fall here. So even if, let's say, New York State passes a law saying you can't burn any high sulfur coal anymore, well, it may not improve the situation that much for us because a lot of these things are coming from other states. So sometimes you have to address problems on a wider scale as a national law.
Does acid rain affect people?
Not really people. I mean, it doesn't have any damage to you or anything, but
Someone like mothers.
no. But one way you see this is on statues. Depending on what a statue is made out of, it can be affected severely. I don't know if you've ever been to like an older cemetery, kind of walked around. If you see sort of the whitish gravestones, they're light in color, they're often worn away that you could almost, sometimes an older one, you may not be able to read the words at all. Those are limestone, those are made of limestone usually, and limestone, acid rain eats away very, very quickly at limestone. And that's why some of those statues, some of those markers have been eroded so much. Like a modern one, like granite, that shiny sort of rock material, that's not affected by acid rain, so those can stand up better. Here's a picture of the statue where the features have been worn off due to acid rain. Again, here's one of those gravestones. This one is kind of neat. This shows a picture of the same statue, okay, about 60 years difference. This is in 1908, and you can see this in 1968. The features have been completely worn away due to the effects of acid rain. You can also see this is a spruce. Spruce forests are very susceptible to damage by acid conditions. This is a spruce forest where the trees basically died off because of this acid rain. And you can see the growth of trees has slowed down because of that as well. Darren?
Like all around like Utah and like all around here, aren't there those green statues?
Yeah, that green is, so the green is a reaction that happens with copper often, but not necessarily due to acid rain. It's sort of a natural, copper as it ages turns color, so that's part of that. All right, another type of pollution is called smog. It comes from smoke and fog combined to form smog, not smog with an AU like the Hobbit. But smog is an environmental pollutant, and it's caused when pollution in the air reacts with sunlight. And it forms something called ozone, which is dangerous for people's health. It's a toxic gas that can damage your lungs over the long term. There's some cities, we don't generally have a major problem with smog here, but in some cities, when you look at the weather in the morning, it'll tell you the temperature and if it's going to rain or not, but it also may give a smog index that tells you how much of this pollution's in the air. And if it reaches a certain level, there's a warning that says you shouldn't go out and exercise. You shouldn't be playing sports outside. You shouldn't go out for a run because you're going to inhale a lot of this and it may damage your lungs. People that have asthma or emphysema, this can irritate it and make it worse. And so it's produced by the emissions from cars and factories and stuff, and it really becomes a problem in cities that are like in a valley. Los Angeles, for example, has an issue with smog, and it's because that sort of settles in the valley and kind of stays there, kind of like fog does. If you ever been a foggy day and you go into like a low area down a hill, it's real foggy in the bottom where it wasn't at the top. Same sort of idea. And this is an example. This is Beijing, China. This is on a day when the smog had lifted versus a day when it hadn't. And you can see the pollution is just this haze of this toxic gas that irritates people's lungs. Dan?
It looks like Godzilla movie, or Godzilla fought a monster movie.
Oh, really? Interesting. Hannah?
I would get like a bunch of giant pans and blow it out of the valley.
Yeah, that's one idea. And this can result in what we call respiratory problems, like I said, emphysema, asthma, things like that. And so how can you help to improve this? Well, basically you have to have cleaner burning fuels. We have to reduce the emission of some of these chemicals by cars. And you know, one thing you have, I don't know how familiar you are, but on all cars there's something called a catalytic converter. Have you ever heard of that?
No, I
Nope.
Nope.
I think I
All right. Well, it's a part of your car that actually, as the exhaust leaves your engine, it goes through this piece of equipment, which helps burn off some of these pollutants so that the exhaust coming out of your tailpipe is a little bit cleaner. In fact, your car won't pass inspection if this piece of equipment isn't working properly. Okay, and that's help to preserve. That's to help preserve air quality. Danielle? Yeah.
Take like water, cars that can run on water, but the wheels are energy.
Yeah, there are other, there's like hydrogen vehicles and stuff. They aren't quite fully developed yet, but there are possibilities.
They have electric cars too, right?
Yep. All right, this will be our last topic here. Ozone depletion. This is an important one. So ozone depletion, there's a layer in our atmosphere. Have you guys heard about this one before?
Yeah.
Okay. So way up high in the atmosphere, miles in the air, is this layer of ozone gas, which has a very important job. It blocks ultraviolet radiation. And why is this a good thing? That it blocks most ultraviolet radiation. Holly?
Because it can harness the get burns by stepping outside.
Yeah, that ultraviolet radiation is what causes a sunburn or suntan, but also prolonged exposure can increase a person's chance of skin cancer because it damages your cells. Okay, and so this blocks a lot of that. If this layer is destroyed, it means more ultraviolet radiation is reaching us, which can lead to greater incidence of skin cancer and eye cancer and so on. And it's being destroyed, or was being destroyed, by a certain chemical called CFCs, chlorofluorocarbons. And this is a chemical that drifts up high into the atmosphere and eats away at the ozone layer. And these chemicals used to be very common. They were in aerosol cans, you know, cans of hairspray and deodorant and stuff like that. And when you use those things, these gases leak out. They used to be in air conditioners. They go up high into the ozone layer and destroy it, making it thinner and thinner, creating an actual hole down near Antarctica. And so that can lead to several problems. I'll go back. Sorry. And the other thing is, the good news is that in the late 80s, I think maybe 1987, there was a international law passed that reduced the use of CFCs because of this problem. And since then, this damage